Hi class. So what we're going to look at now is how do we identify functional groups? All right, so we're going to start with an alkene. And really what you want to pay attention to is the ene here, so the en, is what's going to tell us that there's a double bond. All right, and so what you want to look for is anytime you have a carbon-carbon double bond, it's going to be an alkene. All right. If it's a double bond between a carbon and a different atom, it's probably going to be some other functional group. So your key is some carbon-carbon double bond is an alkene. The same idea, an alkyne, especially the YN, is going to tell you have a triple bond. Now, the tricky thing about the triple bond is we've lost kind of that zigzag form, and there's a carbon on the end of these triple bonds. All right, so if I draw out this structure, it's actually CH3, a bond to a carbon, and then a triple bond between the two carbons, and then another CH3. And the reason why the triple bond we actually draw linearly is to reflect that this 180-degree bond, right? This one's linear across this carbon. And so that's why this is one of the few that we actually show linearly. But it's easy to lose this carbon on the end of each of the triple bonds. The next one is kind of unique, and we'll actually spend a whole chapter with this later on. But when you see a six-membered ring, and there's other ones, but this is the most common aromatic ring, is our benzene ring, is when you have a carbon that's in a six-membered ring with alternating double bonds, right? So it goes double, single, double, single, double, single, all the way around. All right, so it's got to be in the ring, and it's got to be alternating double, single. Now, benzene ring is only one class of aromatics, right? There's a whole set of rules. You have to be planar, you have to be conjugated, you have to be in a ring, and you have to have a certain number of electrons. But for now, let's just get used to seeing that you're in a ring and you're alternating single-double. Right? So double bond, single bond, double bond, single bond. All right, the next one is our fun functional group. So it's an alcohol. So when you think about beer and wine, things like that, the alcohol that they're talking about is the one that's actually shown here. So this is ethanol. And the ethanol means that there's two carbons, right? And then our OH. But an alcohol is specifically anything that has an OH group coming off of a carbon. The other thing we're going to look at, if we look at another alcohol, it's still an alcohol because we have a carbon here at the base, just like we had a carbon here. Now the difference on this is that this one over here is a primary alcohol. And what we want to do is look at the degree of the carbon holding the alcohol. So the carbon with the arrow is only directly bound to one other carbon. So this is a primary alcohol. This carbon here is directly bound to two carbons. So this is a secondary alcohol. And if we drew a tertiary alcohol, the carbon holding the alcohol is got to be bound to three other carbons. So 1, 2, 3. So this becomes our tertiary alcohol. Now, the one thing I would like to point out is that if you had something like this where the chain is linear, we're still going to look at this carbon, and it's still only directly bound to one carbon. There's a couple others, but it's only directly bound to one. So this is still a primary alcohol. All right. So an alcohol is anything that has this OH directly bound to a carbon, and that's going to be our alcohol. One that looks similar to it is our ether. And the key to this is, for ether, I think that there's a carbon on either side of the oxygen. Right? Oxygen, and then there's got to be a carbon on either side of it. All right, so that'd be our ether. An amine is essentially a nitrogen. So you're going to have some nitrogen group bound to a carbon. So we have a carbon here, and this is our primary amine. And the way we look at this is how many carbons are directly bound to the nitrogen. It's only one, so it's a primary amine. Now if we draw another one, remember nitrogen likes three bonds. Right, so if this is a carbon, and we have our CH3 group over here, this one now is bound to two carbon groups, so this would be a secondary amine. And then if we do a tertiary amine, it's going to be bound to three carbon groups. Right? And so that becomes our tertiary amine. And we didn't show it, but we could have. Amines, when they're bound to three things, typically have a lone pair, but we don't know what's drawn in. Right? We just know that they're implied. All right, so remember, for amines, we're looking at how many carbons are directly bound to it. For alcohols, if you guys take a look back up at the top of the page, it's the alcohol, the carbon holding the alcohol. We want to see how many carbons are directly bound to it. All right, so it's a little different, even though we're still using the same names. All right, now if we kind of move forward, we want to look at the aldehydes. All right, so aldehydes are a little bit unique. So one thing I want to talk about before we actually get to the aldehydes is anytime we have a carbon-oxygen double bond, we're going to call this a carbonyl. All right? So this group here is a carbonyl. All right? So a carbonyl is never a functional group. It's always a piece of a functional group. All right? So we'll see a carbonyl in a bunch of the next functional groups we're going to look at. All right? So the way that you can see an aldehyde is it has a carbonyl here on the end, and it has a hydrogen. All right? So it always has to be on the end of the chain, and it's a carbonyl with a hydrogen on one side and a carbon chain on the other. Right, the difference between an aldehyde and a ketone is a ketone always has to have a carbon on both sides. Right, so they both have carbonyls, but a ketone has to have a carbon on either side of the carbonyl. Right, an aldehyde will have a hydrogen to one side. All right, the next one, a little bit tougher, is our carboxylic acid. And the tough thing about this is essentially you have an OH group here and a carbonyl group here. But do you notice how they're attached to the same carbon? It's the same carbon that holds the OH and the same carbon that holds our carbonyl. All right? And so that's going to be our carboxylic acid. And just make sure that these are all together a carboxylic acid. Okay? If there's a carbon in between, so let's say we had something like this, then the difference would be this is a ketone, and then our OH is our alcohol over here. Right? So that would be the difference. But since they're on the same carbon, they're a carboxylic acid. All right, the next one, an ester. So an ester is something that has a carbonyl and an ether on the same carbon. Right? So it looks just like our carboxylic acid, but on the other side of the oxygen, instead of having hydrogen, we have to have some carbon group. Right? It can just be one carbon or it can be a long carbon chain. It doesn't matter. But you have to have a carbonyl and then some oxygen carbon group on the other side, and that'll be our ester. All right, our amide is just a nitrogen version of this. All right, we have our carbonyl, and then now we have some amine. All right, so we have our nitrogen with a carbon group, and in this case, it doesn't matter what's on the other side of the nitrogen in terms of carbons or hydrogen. So we could also have NH2, that's still our amide. Right? Or we could have something that looks like this with a nitrogen and a bunch of carbons. Right? CH3, CH3. All right? It's still an amide. All right? The key component is this carbonyl nitrogen. All right? And an ester is the carbonyl oxygen carbon. All right? And so those are kind of the big ones. So those are the primary functional groups we're going to work with in the course this year. All right, so make sure you guys can pick them out of a large group of molecules.